Hello friends, dear viewers, students, professional people, good afternoon. This is Abdul Halim and we welcome to you my channel Flexomaster, and today we are going to study the paper and paperboard packaging, chapter number 20, the last chapter for this subject. Let's start. So we will continue carton styles. We are continuing from the previous chapter. The top and bottom flaps can be glued with hot melt or water-based adhesive, or a tuck flap can be incorporated in the design for mechanically closing and opening. See in the figure number 11. The left diagram shows a reverse tuck uh, style carton, and the right in the aeroplane tuck. The aeroplane tuck style use more paper board than the reverse tuck style, but some consider it aesthetically more pleasing. Aeroplane tuck, either desk flap, top closer panel, tuck flap. So it is having a different dimensions. So for the illustration purpose only, I am showing this design. A cut is often made at the ends of the flap creases, which creates a mechanical lock with the minor flaps helping to prevent the carton opening in the transit. Figure number 13. So it continue. The top load carton is supplied to the packer filler as a flat blank. It is formed through a die, and a side panel are mechanically locked or glued, normally by hot melt adhesive. The product is then filled through the large top aperture and the lid is closed. The lid design can either be tuck flap as the drawing, or as the flap can be glued to the carton. There is a variety of mechanically locked and glued cartons and trade made in this way. The type of tray, locked or glued, is used to collate cartons prior to shrink wrapping for delivery to the customer. The lock tab version allows for hand assembly on the production line. See in the figure 15, top load carton lock tab design. The tapered style means that they can be stacked on one inside the other with the lid cup up, saving space and ensuring they are ready to and open to enable speedy packing of goods at the counter. Top load carton heat sealed web cornered. Now plastic coated paper board can be formed into a heat sealed web cornered tray with horizontal flanges, which will heat seal to a plastic or plastic coated paperboard lid. This style of tray can be filled with product, the lid sealed on, and whole pack frozen ready for distribution. Another style of top load carton, which can be supplied ready glued and folded in, as shown in the figure number 17. This is 6 corner glued folded design. A special 4 or 6 point gluing procedure will with extra diagonal creases, allowing for these cartons to be laid flat when supplied, negating the need for any machine erection and gluing as at the customer. Example, cake shop. This style of carton often includes a clear window patch as well. Cartons are also used to make multi-packs. Figure 18. The board is either a special craft board and high water resistant and good water wet tear strength, or a specially treated recycled board to protect it from moisture and water penetration. These boards are commonly referred to as carrier boards. Here is showing that the top load carton, again multi-packs for dairy packs left, and carbonated drinks right. So you can insert the carbonated drinks in like Pepsi, 7-Up or Coca-Cola, etc. And here is the multi-pack for dairy packs like yogurt, etc., the creams and so on. So cartoon making. The cartoon making process varied, but there are some common steps. These are printing, cutting and creasing, window patching, gluing. Prior to printing, the paperboard as received is conditioned either in the warehouse or by the set side of the printing press for 72 hours. This is to ensure the material is consistent, especially with respect to moisture content. If it is not, this will affect the print quality. Other areas which may affect print quality relate to the reeled or sheeted board. Checks must be made for cleanliness, especially on the edges, as slitting and cutting dust can transfer to the surface of the substrate, creating imperfection on the printed surface. As the paperboard passes through all the printing presses, it is bent by the tension and feed rolls. This will break some of the fibers, reducing the stiffness and strength of the board, and therefore the resulting carton. Mechanical fiber is more susceptible to this than chemical fiber, as it is shorter in length and more brittle. The main three printed methods are offset lithography, which is normally sheet fed, and gravure, and flexography, which is normally reel fed. The relationship of the direction of a print to fiber orientation within the sheet is very important, as discussed earlier. The tolerances and print panels need to be matched to those to the cut and crease die form. Failure to do so will result in the cartoon not being cut and creased in line with the printed design, resulting in misregister of print to structural design. Cutting and creasing is carried out using a flat die or sheet fed materials or a rotary die for reel fed materials, as shown in the figure 19. Here the cutting and creasing operation, or box cutting as it is known, it is as important as the print operation. If the cartoons are not cut and creased correctly, their performance will be impaired during the following stages of conversion: filling and distribution. Cartoons are cut and creased using a form. To enable the cutting and creasing operation to be controlled, a counter plate is placed on the base of the press, exactly in line with the form. The form is made from plywood and steel cutting knives and creasing rules inserted into grooves, which are commonly cut using a laser for high accuracy. Especially foam rubber pads are placed at either side of the cutting knives to act as a spring, which remove the board from the blade after the cutting operation. The cutting knives blades are not continuous but designed in such a way that when the cutting operation is complete, they leave nicks between the individual cartoon cutouts. As there were one sheet when the waste is stripped away, the nicks are broken at the next stage. The nick is made by designing notches into the cutting knives, the severe depending on the paperboard type as thickness. The stronger the board, the narrower the notch. By mistake, this is figure number 21, and it is position of the nicks. And figure number 21 is die cutting rule with a notch. In general, the depth of the notch is made slightly greater than the thickness of the board. The strength requirement of the nick depends on many factors. This include grain direction of the paperboard. MD is stronger than CD. Method of making the notches. Quality of notches must maintain the integrity of the cartoon within the sheet without breaking. but must be as small as possible so as not to seen on the final cartoon. Strength of the foam rubber to release the board from the knife. Incorrect materials could put unnecessary strain on the nick, causing it to break prematurely. Dimension of the nick normally 0.4 to 1 millimeter. How the nicks are arranged is important because if they are not placed evenly across the edge of the cartoon, undue pressure will be placed on the cut blank, resulting in premature breaking of the nicks. Number of nicks per cut edge. More nicks, more strength. Moisture content of the paperboard. As moisture content increase, the strength of the nicks decrease. Quality of fiber used to make the board. The weaker or more consistent the fiber, the wider the nicks needs to be. Knife edges blunt over time and need replacing. The speed at which they do so varies with the type of board being cut. Plastic coated boards often require specially designed cutting knives. It is uneconomical to use a form where the knives are blunt or incorrect for paperboard being cut, as this will result in poor performance on the cartoon erecting machine and in use. The important operation performed by the form is creasing. Well-performed creases are essential for correctly formed cartoons. The quality of crease, as therefore efficiency of making up cartoons on the packaging line, depends on number one, the height and width of the creasing rule with respect to the paper board being creased. The creasing rule is designed for a narrow range of paperboard thickness, and if the length of the rule is too long, it will damage the crease area, and if too short, it will produce an imperfect crease. The thickness of the make ready see below. Here, crease depth too deep, too shallow, and here too narrow and too wide is the depth, and it is the width. Surface plies will crack here. Good creasing area is this. The board will crack here. The poor corner when folding, too wide crease, and this is the width and depth of the crease. The width of the make ready groove in relation to the thickness of the crease rule. If the make ready groove is too narrow, the crease is likely to form too tightly. If too wide, the crease forming operation is not tightly controlled. So, thank you very much for your time, and we complete here the paper and paperboard packaging chapter, and we will continue in the next chapter. Hello friends, hello viewers. Uh, we have completed the chapter number 20 today, and this will complete our subject paper and paperboard packaging, and we will continue our next video in the next chapter for other subject. So until then, please subscribe our channel, like and comment, and if you have if you need more information, please write an email to us. Thank you very much. See you soon.